So what is a resonance RLC circuit? And what does a resonance means? We know that XL is equal to XC. When XL is equal to XC, the resonance condition takes place. Okay. So at that time, what happens is that the current current and the voltage, okay, so current and the voltage, here it is V or E, okay, the supply voltage is V or E. So here the supply voltage V or E is equal to VR. So XL is equal to XC. When XL is equal to XC, the power factor is unity power factor. So what is the definition of resonance is that in an RLC AC circuit is said to be at resonance if the applied voltage and the current are in phase. That is, the circuit behaves purely resistive and the power factor of the circuit is 1 or unity. That is unity. So in the series resonance condition, so at resonance the power factor is unity. So Z is equal to R plus J XL difference XC, difference between XL and XC. Okay, this in terms of we can write it as Z is equal to square root of x square plus xl minus xc the whole square. So xl minus xc is equal to 0, xl is equal to xc. So what is resonant condition? So I am writing it as, we will write it as omega L. Here it is R is resonant condition, omega RL is equal to 1 by omega RC. So here it is XL is equal, that is XL is equal to XC, substituting that values. Here we are getting omega R square is equal to 1 by LC. So omega R is equal to 1 by root of LC. So angular resonant frequency omega R is equal to this radians per second. So what is resonant frequency is equal to omega R is equal to 2 pi Fr. So here it is Fr is equal to omega R by 2 pi. Here it is nothing but what is your value of the omega R is nothing but 1 by root of LC. It is cycles per second or hertz frequency. At resonance power factor, so cos phi is equal to 1. So we are writing it as R by Z is equal to 1. So is it Z is equal to R. Okay, the impedance is equal to purely resistance. From this impedance triangle, here this is R, this is XL minus XC. So cos phi is equal to, okay, what is cos phi is equal to adjacent by hypotenuse, R by Z. So the value is R by Z is equal to 1. Power factor is 1. So Z is equal to R. So now this is the reactance curve. This is purely inductance. This is purely capacitance. And here if you see, this is XL minus XC. When the XL minus XC is being, this curve has been attained at resonant frequency FR. Okay, this is the curve versus the impedance versus the frequency, and this is the F naught. And this is the value, that is Z is equal to R plus J into XL minus XC. So this is the curve for frequency versus the input current with different voltages, and this is the impedance triangle, and this curve represents the frequency and the current. Okay, this is the maximum Imax is E by R. So F1 and F2 are the lower half power frequency. This is the upper half power frequency, and this is the resonant frequency. and at this point 1 and 2, here I1 is equal to I2. Okay, so here it is power factor is leading and here the power factor is lagging. So the two frequencies at which the power is half the power at the resonance are called as the half power frequency. So at this frequency the two power will be half, okay, of the total power. So at resonance, that is at the two frequency at which the powers is half power at the resonance are called as the half power frequencies. So frequency greater than the resonant frequency is called as the upper half power frequency, and the frequency less than the resonant frequency is called as the lower half power frequency. Okay, this is the lower half power frequency, this is the upper half power frequency. Okay, here I1 is equal to I2 is equal to I max by root 2. Okay, here I1 is equal to I2. So it is maximum current divided by root 2, I max by root 2. So which is nothing but which is equal to E by Z. Okay, input voltage by the total impedance. So after what is finding out the Z value is equal to Z we are taking out here, and here it is Z is equal to 2 into E by I, which is nothing but Z is equal to 2 into R, E by R. Voltage by the current is equal to the resistance. So Z is equal to 2 into R. So purely resistive the circuit is. So cos phi is equal to R by Z. Okay, adjacent by hypotenuse. Adjacent by hypotenuse side. So which is nothing but the R by Z is equal to 1 by root 2 from this expression. So it is 0.707, or we can write it as phi is equal. Here it is we are writing XL minus XC is equal to R at both the frequencies. First case 1 we are taking it as XL minus XC is equal to minus R, or here we are writing it as XL instead of this substituting omega 1 L minus 1 divided by omega 1 C is equal to minus R. So equating, there is solving this equation. Okay, we are getting this value of the omega 1. Okay, here it is we are getting it as omega 1 is equal to this expression. Okay, F1 is nothing but omega 1 divided by 2 pi. So omega 1 we are substituting it, and then omega 1 you are finding out from this expression. Okay, and then we are getting neglecting the R by 2L the whole square compared to 1 by LC, we get F1 is equal to FR minus R by 4 into 4 pi L. Okay, this is the lower cutoff frequency, and this is case 2 is F2 upper cutoff frequency. XL minus XC is equal to R. Previous case it was minus R, lower cutoff frequency. So simplifying this, substituting this value, and we are simplifying it and finding out omega 2. Then what is omega 2 is nothing but here F2 is equal to omega 2 by 2 pi. Substituting this value we are getting the value F2 is equal to FR plus R divided by 4 pi L. So what is the bandwidth? Bandwidth is nothing but the bandwidth is defined as the band of frequency between F2 and F1. So it is nothing but F2 minus F1. So here you are having the F2 value